Last year's vehicle at high speeds became unstable because the steering was oversensitive. This oversensitive steering would also hinder the driver, for whenever turning, the control arm would rotate into the driver's leg, making it difficult to pedal and steer at the same time. As shown by the prototype, the new controls will travel in tracks beside the legs, turning the entire front axle to a calculated angle.
The theory behind our steering mechanism is instant centers. The instant center for the first axis is perpendicular to the front axle. The second instant center line comes from the rear axle, also perpendicular. When the vehicle is driving straight forward, the instant center lines do not intersect, which means the circle is infinite, which makes sense. However, when the front axle turns, the instant center line now will intersect the rear instant center line. This resulting line will be the turn radius with respect to the front axle, which is larger than the turn radius to the respect of the rear axle. Therefore, in our design, we chose to fit this one to conform to the requirement of 8 meters. However, to make sure we fit within the 8-meter requirement, we divided this by a design factor of 1.5, resulting in a target of 6 meters. In SolidWorks, we set this distance to 6 meters, and our team had originally designed the bike to be 5 feet. That defined this angle as 20 degrees. Therefore, we knew that in our design, we had to be able to turn the front axle 20 degrees. In reality, though, when we finished building the bike, it was 4 feet long, which means that this line would become shorter. As you decrease the distance between the front axle and the rear axle, you decrease the required angle. This is about 17 degrees. Therefore, our design for 20 degrees exceeds the required design of 17 degrees, which exceeds the base requirement of 8 meters.
This can be visually demonstrated by attaching a pole to the front axle and rear axle of a regular bicycle and then rolling the bicycle in a circle. The instant center will remain constant.